according to the National Electrical Code Section 210.11. C.3. Bathroom branch circuits require specific attention. The question addresses the practice of combining receptacle circuits for multiple bathrooms, such as a master, guest, and powder room, onto a single circuit, possibly including lighting from an adjoining room if the load allows. The NEC mandates that at least one 20-ampere branch circuit be provided to supply the bathroom receptacle outlets. The key provision is that such circuit shall have no other outlets. The exception to this rule applies only where the 20-ampere circuit supplies a single bathroom, in which case outlets for other equipment within the same bathroom are permitted to be supplied in accordance with Section 210.23. Considering these points, connecting multiple bathrooms to a single 20-ampere receptacle circuit and including lighting from an adjacent room presents a potential code violation. Because the exception only applies to a single bathroom, sharing the circuit across multiple bathrooms disqualifies it from the exception. Therefore, the most appropriate approach is to provide a dedicated 20-ampere circuit for each individual bathroom. This dedicated circuit can supply both the receptacle outlets and the lighting within that single bathroom, aligning with the exception provided in the code. It's important to note that the code references examples done A done, B D2, B and D4, and Annex D, which offer further illustrations and clarifications of these requirements. When determining the correct wiring configuration, several factors must be considered. Firstly, the load calculation for each bathroom is essential. This involves adding up the anticipated amperage draw from all devices and appliances that may be used in the bathroom simultaneously. Secondly, the voltage drop in the circuit must be evaluated to ensure that it remains within acceptable limits, typically no more than 3% for branch circuits. Thirdly, the size of the conductors must be adequate to handle the calculated load and comply with NEC Table 310.15, B16, which specifies the ampacity of conductors based on their insulation type and ambient temperature. Fourthly, the overcurrent protection device, such as a circuit breaker, must be appropriately sized to protect the circuit from overloads and short circuits, in accordance with NEC Section 240.4. Fifthly, ground fault circuit interrupter, or GFCI, protection is required for all receptacle outlets installed in bathrooms, as per NEC Section 210.8. A1. This protection is crucial to prevent electrical shock hazards in damp or wet locations. Regarding the exception to NEC 210.11, C3, where a single bathroom can have other equipment on the 20-ampere circuit, it's vital to understand the limitations outlined in Section 210.23. This section specifies the permissible load on a branch circuit based on the rating of the overcurrent protection device. For a 20-ampere circuit, the total cord and plug connected load shall not exceed 16 amperes. Any permanently connected appliances, such as exhaust fans or heaters, must also be factored into the total load calculation. It is also important to ensure that the branch circuit does not supply any non-fastened in-place utilization equipment. Consider a scenario where a master bathroom includes receptacle outlets, lighting, and a ventilation fan all supplied by a single 20-ampere circuit. Firstly, calculate the total load of the lighting fixtures. If the lighting consists of several LED fixtures with a combined wattage of 100 watts, the current draw would be approximately 0.83 amps at 120 volts. Secondly, determine the current draw of the ventilation fan. A typical bathroom fan might draw around 1 amp. Thirdly, account for any receptacle outlets that may be used to power hair dryers, curling irons, or other appliances. Assuming the maximum potential load from these appliances is 12 amps, the total load on the circuit would be approximately 13.83 amps. This falls within the 16 ampere limit for cord and plug connected loads on a 20 ampere circuit. Furthermore, ensure that the wire gauge is appropriate for a 20 ampere circuit. Typically, 12 American wire gauge copper wire is used for 20 ampere circuits. The conductors must be properly installed and terminated to prevent loose connections, which can lead to overheating and electrical hazard. Another consideration is the placement of receptacle outlets in the bathroom. NEC section 210.52. D requires at least one receptacle outlet to be installed within 36 inches of the outside edge of each basin. These receptacles must be readily accessible and should not be located behind the basin. The height of the receptacle outlet should be between 12 inches and 48 inches above the finished floor. The importance of GFCI protection cannot be overstated. GFCI devices constantly monitor the current flowing through a circuit and quickly interrupt the power supply if a ground fault is detected. This prevents dangerous electrical shocks and is particularly important in bathrooms where water is present. GFCI protection can be provided by using GFCI receptacle outlets or by installing a GFCI circuit breaker in the panel. When installing or modifying electrical circuits in a bathroom, it is always recommended to consult with a qualified electrician. The electricians have the knowledge and experience to ensure that the wiring is installed safely and in compliance with all applicable codes and regulations. Improper wiring can lead to electrical hazards, including shocks, fires, and equipment damage. Therefore, professional expertise is essential to protect the safety of occupants and the integrity of the electrical system. To summarize, while it may seem thrifty to combine receptacle circuits for multiple bathrooms, the NEC generally requires each bathroom to have its own dedicated 20-ampere circuit. The exception to this rule only applies when a single bathroom is served by the circuit, and even then strict limitations on the load are in place. By adhering to these requirements and taking appropriate safety measures, you can ensure that your bathroom electrical system is both safe and code compliant. Consider the impact of future expansion or renovation. If you anticipate adding more electrical devices or appliances to the bathroom in the future, it is wise to install additional circuits or increase the capacity of existing circuits. This will prevent overloading the circuits and ensure that the electrical system can handle the increased demand. Additionally, it is important to properly label all circuits in the electrical panel. This makes it easier to identify and troubleshoot circuits in the future. Use a circuit directory to clearly indicate which circuits serve which areas of the house. This can save time and effort when performing maintenance or repairs. Regularly inspect electrical outlets, switches, and fixtures for signs of damage or wear. Replace any damaged components promptly to prevent electrical hazards. Look for cracked or broken outlets, loose wiring, or flickering lights. These are all indicators of potential problems that should be addressed by a qualified electrician. Be aware of the potential for water damage to electrical components. Water can conduct electricity and create dangerous shock hazards. If any electrical components have been exposed to water, do not touch them. Turn off the power to the affected circuit and contact a qualified electrician to inspect and repair the damage. When using electrical appliances in the bathroom, keep them away from water sources. Never use a hairdryer or other electrical device near a sink or bathtub filled with water. This greatly increases the risk of electric shock. Consider installing tamper-resistant receptacles, or TRRs, especially in homes with young children. TRR have internal shutters that prevent objects other than electrical plugs from being inserted into the slots. This can help prevent accidental electrical shocks. Periodically test GFCI receptacles to ensure that they are functioning properly. Most GFCI receptacles have a test button that you can press to simulate a ground fault. If the GFCI receptacle does not trip when you press the test button, it should be replaced. Keep electrical cords and wires in good condition. Replace any cords that are frayed, cracked, or damaged. Avoid running cords under rugs or furniture, as this can damage the insulation and create a fire hazard. Unplug electrical appliances when they are not in use. This can save energy and reduce the risk of electrical shock. Install smoke detectors in all bathrooms. Smoke detectors can provide an early warning of a fire, giving you time to escape safely. Test smoke detectors regularly to ensure that they are functioning properly. Consider installing carbon monoxide detectors in homes with fuel-burning appliances, such as furnaces, water heaters, or gas stoves. Carbon monoxide is a colorless, odorless gas that can be deadly. Carbon monoxide detectors can alert you to the presence of this gas, giving you time to evacuate the building. Always hire a qualified electrician to perform any electrical work in your home. Electricians have the training and experience to ensure that the work is done safely and in compliance with all applicable codes and regulations. Avoid attempting to do electrical work yourself unless you are properly trained and qualified. Obtain the necessary permits before starting any electrical work. Permits ensure that the work is inspected by a qualified inspector, who can verify that it meets all applicable codes and regulations. Keep electrical panels clear and accessible. Do not block access to electrical panels with furniture or other objects. In an emergency, it is important to be able to quickly access the electrical panel to shut off the power. Educate children about electrical safety. Teach them not to play with electrical outlets, cords, or appliances. Explain the dangers of electricity and how to avoid electrical shocks. Follow the manufacturer's instructions when using electrical appliances. Read the instructions carefully before using any electrical appliance. Use the appliance only for its intended purpose and follow all safety precautions. Avoid overloading electrical circuits. Overloading circuits can cause them to overheat and trip the circuit breaker. If a circuit breaker trips frequently, it may be a sign that the circuit is overloaded. Reduce the number of appliances plugged into the circuit or have a qualified electrician install an additional circuit. Use surge protectors to protect electronic equipment from power surges. Power surges can damage electronic equipment, such as computers, televisions, and stereos. Surge protectors can help prevent this damage by diverting excess voltage away from the equipment. Avoid using extension cords as a permanent solution. Extension cords are intended for temporary use only. If you need a permanent outlet, have a qualified electrician install one. Keep electrical equipment clean and dry. Dust and moisture can damage electrical equipment and create electrical hazards. Clean electrical equipment regularly and keep it dry. If you are unsure about any aspect of electrical safety, consult with a qualified electrician. Electricians can provide expert advice and guidance on all aspects of electrical safety. Remember, electricity is a powerful force that can be dangerous if not handled properly. By following these safety tips, you can help protect yourself and your family from electrical hazards. The information provided here is for general guidance only and should not be considered a substitute for professional advice. Always consult with a qualified electrician before performing any electrical work. Furthermore, local codes and regulations may vary, so it is important to check with your local authorities to ensure compliance. Staying informed about electrical safety and adhering to code requirements is essential for creating a safe and comfortable living environment.